Hi, my name is Andrew Stanton and I'm here today to present my Arduino-based Pulse Oximeter project. Just a quick overview, pulse oximetry is the measure of oxygenated red blood cells in your bloodstream. The average person has an SpO2 between 95 and 99%. Now, as you can see in the schematic, my system utilizes an Arduino Uno, a MAX 30102 pulse oximeter device, a SSD 1306 128 by 64 display, 3 LEDs, and 330 ohm resistors in series with those LEDs. Moving on to the software, this product utilizes the SparkFun MAX 30102 library to calculate the blood oxygen content. This algorithm functions by finding the peaks and values of the cardiogram provided by the MAX 30102 chip. It then takes the ratio between the DC and AC component of both the red and infrared signals, sorts the ratio values into ascending order before selecting the median value. The median value is then used to create a moving average which gets plugged into the formula below. The SpO2 and heart rate then get passed back to the main program. As for the main program, void setup begins interface with a computer, initializes pins 13, 12, and 8 for LED outputs, starts the SSD 1306 display, and initializes the sensor. The looping program contains the repeating code that calls the SpO2 algorithm, prints the sensor data and algorithm results to the computer console, and finds the maximum, minimum, and average of the SpO2 data. It finally then prints the max, minimum, and average, along with the heart rate to the 128 by 64 display. Here's just a quick demonstration of the pulse oximeter in action. As you can see, the data on the display and the green LED is lit for the SpO2 being above 95. The Arduino platform proved to be very limiting in its applications due to its low processing speed and small amount of dynamic memory. The dynamic memory prevented any meaningful modifications from being made to the project. My initial intention had been to make an NFC reading device that would both read and save the previous pulse oximetry data to an RFID tag. However, the limitation in memory prevented that from functioning. Additionally, the device proved to have stability issues when more than 80% of the dynamic memory was being used, with the original unaltered SpO2 algorithm causing frequent device crashes and unreadable data. Another issue with the project was the low accuracy and low precision of the data collected. I measured the heart rate every 6 seconds on both the Arduino and a watch that has a laser heart rate sensor over the course of a minute. The 10 values, as you can see, wildly differ for the Arduino, while the control device were very consistent. As for the conclusion, creating a pulse oximetry device based off Arduino is not recommended as the platform is inaccurate, it lacks versatility, and is more expensive than pre-made alternatives. The Arduino alone costs $10, which is as much as some pre-made other pulse oximeters that have a much higher accuracy. Also, the dynamic RAM limitations, as well as the processing limitations, prevented any meaningful modifications from being implemented in this project. The only reason to replicate this project would be for educational purposes. Thank you and have a wonderful day.